All right, in this section, let's put together kind of all of the shapes that we've done and do some describing. We're not going to solve all of these, but describe how we would find each area and perimeter. So, for instance, we all know about area addition and subtraction. So let's just review that concept real quick. So here I could drop that line in there, and then I could say that this is capital A sub 1 and capital A sub 2 for area 1 and area 2. And then our area total would be area 1 plus area 2. For perimeter, we always know that it's the total outside solid shape. So of course you would start in one corner, like here, trace all the way around like you're seeing me do with my cursor, add all of those up. So I'm just going to say add all sides. All right, for this one then, if I'm asking you just for the area and the perimeter of the shaded part, right, all of this space in here like we've been doing, then of course we're going to keep with the same thing. We're going to say the area is going to be the area of the large rectangle, so the big rectangle, which would fill it all in. So I'm just going to notate it like this, just say area of the large rectangle, and you're going to take away the inner rectangle, so minus the area of the small rectangle. For perimeter, remember you want to keep cows, people, whatever, inside the shaded region. So you would have to build two fences. So you need to build this outer perimeter fence, and you need to build the inner perimeter fence. And if you were going to buy the wood to build those fences, you would add those perimeters together. So I'm going to call this outside one, P sub 1, perimeter 1, and the inside one, perimeter 2. And for total perimeter, we would do perimeter 1 plus perimeter 2. All right, so for this one, find each area and perimeter. Again, it's of the shaded region that we're talking about. So I highly suggest, again, that you start with writing the original equation. So for instance, area of a circle, we know, is pi r squared. When I give you this picture, okay, so that you're not guessing, well, is that a third of a circle or a fourth of a circle or half of a circle? When I give you a picture like this for sure is the diameter. So I'm going to erase this, but if I were to draw the entire circle just for you to visualize it, we're saying this is the diameter, right? 8's the diameter, 4 is the radius, since it's half of it. Okay, so then if area is pi r squared, we can see that this is a half of a circle. So I'm going to say it's a half of pi r squared. All right, so this is going to be 1/2 of pi. The radius we said would be 4 squared. And then practicing with our different types of directions, if I asked you for answers exact or in terms of pi, you would say 4 squared is 16. Half of 16 is 8. 8 times pi would be 8 pi units squared. That would be if I'm asking you for exact or in terms of pi. If those were the directions. Okay, if you go ahead and calculate that as a decimal, that's 25.13 units squared. We're rounding to the nearest hundredth. That would be if I ask you for a decimal answer. So always just follow those directions. That's super important to read those first and know where you're headed. All right, so perimeter. Well, first I need to find this, which we know is called circumference for a circle, and that is half of a circle. So I'm going to call this C so that we just know what we're doing. C for circumference. So I'm going to find circumference first, right? So it's going to be a half of a circle, and we know circumference is 2 pi r or pi d. So it's going to be a half of 2 pi r, or If you choose to do pi d, then it's a half of pi d. Okay, remember you typically always will see me do pi r, 2 pi r. All right, so then this is going to be, the circumference will be 1/2 of 2 times pi, and the radius is 4. All right, so our circumference for our half circle is the following. Half of 2 is 1. So I'm just looking at 1 times 4 times pi, which would be 4 pi. Okay, keep that exact because I only went around once at the end. And now I'm doing literally perimeter, right? So perimeter is the distance around the outside of an entire shape. So this is called circumference, right? So it's the C that we just found. Plus, to get back to where we started, I have to go another 8. So C plus 8. All right, so again, practicing then with those different directions. If I asked you for an exact answer for perimeter, you would tell me, since C is 4 pi, you would tell me 4 pi plus 8. Those are not like terms. Perimeter is a distance, so that's units. And again, that would be if I asked for it to be exact or in terms of pi. If I ask for a decimal, you need to practice this on your calculator. Okay? Pushing equals is a big, important task on most of your guys' calculators. So please push 4 times pi, push equals, get that number, and then say plus 8 and push equals. Round once and only once at the end. If you're doing that correctly, you should be getting 20.57 units. If I ask you to give an answer as a decimal. Okay. All right, for the next one. So this is, again, me trying to find the area of just the shaded region. So again, we want to think about outer shape and inner shape. All right, and then I guess a little bit of proving to you that this outer shape would be a square. So here's the thing. Maybe don't write this down or just watch for a second. If this length is 10 for the side, put that in an important place for the circle. So as the circle is concerned, isn't that length the same as the diameter? All right, well, if diameter can go in any direction, well then, if that was 10, wouldn't this also be 10? Proving to you that this side would be 10. Okay, so I hope that helps you see that that would actually be a square, since all of those sides would equal 10, due to the diameter of the circle being 10. All right, so anyway, I'm going to do the area. Total area will be the area of the square, right, the outer big shape, minus the area of the circle, the inner smaller shape. All right, so writing down those equations again, area of a square is side squared, minus the area of a circle is pi r squared. All right, so the sides are 10, like we just said. So we're looking at 10 squared minus pi. The radius, if that whole diameter is 10, then the radius would be 5. So we're looking at pi times 5 squared. All right, so an exact answer would be 100 minus 5 squared is 25, so 25 pi. Those are not like terms. So exact or in terms of pi, it would be 100 minus 25 pi units squared. And carefully, don't just say you know how to do it, practice this. Type in 100 minus 25 times pi and push equals. Some of you might have to practice and do 25 pi and get that sitting on your calculator first, and then say 100 minus answer. Okay, practice with that answer key that we've talked about. And you should get 21.46 units squared if you round once and once only to the nearest hundredth if I ask you for a decimal answer. Now perimeter, again, remember, since it's a shape inside of a shape, you're just adding them together, right? So the perimeter should be the outer fence, which is the perimeter of a square, which is 4s, plus the perimeter around a circle is called circumference, right? And that distance is 2 pi r. It could also be pi d. So I'll just say the other option would be 4s plus pi d. But you know that I'm going to use the 2 pi r, okay, more often than not. So our perimeter is going to be 4 times the side length of 10 plus 2 pi times the radius of 5. So hopefully you're starting to notice that it's always easier, whether the directions say decimal or not, it's always easier to get an exact answer first and then actually type that in your calculator to get the decimal. So you should be saying the exact answer would be 40 plus 2 times 5 is 10, so 10 pi. Those are not like terms, so that would be your answer with units. Again, if it was exact. And 71.42 units if the directions said to give decimal answers. All right, for these next ones, let's just describe how we would find the area and the perimeter. Okay, we won't actually calculate them because we don't have any numbers. Plus, that's just what we need to be practicing with. So when I see something that looks like this sort of capsule looking thing, okay, like a capsule, then you want to know that this would be a half circle, a rectangle in the middle, and another half circle. So the big thinking is also this half circle and this half circle. If we said every time we draw one of these, it's the diameter of the circle. Think about putting these two together, right? If you were to bring this half circle over with this half circle, you've created a full circle. So you will hear me talk about that as part of this. Focusing on the rectangle, remember this is your base, this is your height. So of course this is B and H as well. All right, so we're ready to say the total area would be, filling in the shaded region, it would be the area of this rectangle plus the area of, well, half circle plus half circle, like we already talked about, would just be the area of the circle. So total area would be the area of the rectangle plus the area of the circle. Okay, so area of a rectangle is base times height, lowercase bh, plus the area of a circle is pi r squared, lowercase r. All right, then perimeter. Again, we're trying to find the perimeter of the total outside solid shape. So I'll take care of these two parts here and here by saying b plus b is 2b. So perimeter would be 2b. And then this distance here and here is just the distance around the outside of a circle, right? And that is called circumference. So we're going to say 2b plus capital C for circumference. All right, in other words, 2b plus circumference is 2 pi r. That's what I'm going to go with. For those of you that are still doing circumference as pi d, then you might be saying 2b plus pi d. All right, next one. Let's go with area first. So we're looking for the shaded region. So I'm going to do area of this big circle, and I'm going to take away the area of the small circle. So I'm going to fill in the equation sort of as I go also. So area is pi r squared and I'll say pi r squared of the large circle minus pi r squared of the small circle. Okay, we'll call that good enough. Perimeter. Perimeter for circles, remember, is called circumference. And again, if I wanted to keep something in the shaded region, I would need to build this fence and this fence and add them together. I'd have to go buy both fences or the amount of material for both fences. So this is C sub 1 for circumference 1, and this is C sub 2 for circumference 2. So my perimeter of the whole shaded region would be circumference 1 plus circumference 2. All right, for this next one, I'm sure you've seen this symbol before, and I'm just going to draw this in for you to be able to see kind of how I'm looking at this. All right, so I'm going to go ahead and draw that in so that it looks like the outside of, do the best you can. There you go. So what I'm saying is this outside is one circle. I'll call it circle 1. And this inside one, if I were to drop this, remember we said these would all be half circles. This area here is the same as this area here. So I'm going to say that those are equivalent. Okay, so we've got the big circle and we've got the little circle that we're also dealing with. So for area, what I'm thinking is this. If I were to pick this part up and put it over here, it would fill this in and this would be a complete half circle. It'd be half of the big outer circle. All right, so our area is going to be literally just a circle, pi r squared, but it's half of it. So it's going to be pi r squared with the radius being the radius of circle number 1, this radius. Okay, so this is going to be a half of a circle, and it's a half of pi r squared. Now for perimeter, right, perimeter just means the distance around the whole outside solid shape, right? So our way to grab a hold of that is the following. This big circle has a circumference C sub 1. This smaller circle, right, if you were to just slide this down, put it here, have this smaller circle, has a different circumference C sub 2. This would be part of it, and this would be part of it. All right, so our total perimeter is going to be from here to here. This is circumference 1, right? C sub 1, but it's half of a circle, so it's a half of C sub 1. And I need to add to it this half and this half of C sub 2, so a full C sub 2. And if I need to make it easier to highlight for you, I can tell you that this part was this part that I'm highlighting right here. Again, it's C sub 1, but half of that. All right, next shape. Next shape then. So this sort of ice cream cone looking thing, right? And we're going to assume that it is a, we'll put some marks in here. If it's a perfect cone, it would be isosceles, right? So those sides would be equal. Let's give them length of x so that we can talk a little bit more about it. We also know for finding the area of a triangle, right? Because eventually I'm going to do a triangle and half of a circle for area. Well, we also know that we're going to need to find area by doing 1/2 base times height. Remember, for an isosceles triangle, you have to drop an altitude, which meets at a right angle. And that is how you would find this area, right? Because the whole base and the whole height have to meet at right angles. So keep that in mind as well. All right, so here we go for area. For the total area of the solid shape, you'd be doing the area of the triangle plus the area of half of a circle. Area of half circle. All right, so the area would be, for a triangle, is 1/2 base times height. That's why we drew that stuff in there, so we could do base and height, which by definition meet at right angles. Plus a half a circle would be half of pi r squared. Perimeter. If you're going around the total outside shape, well, you'd be doing, if we started here and traced, you'd be saying x plus this is circumference, right, of half of a circle. So you'd be saying x plus 1/2 of capital C for the circumference of the circle. Okay, which equals, if we fill in a little bit more, x plus x, you could also say that's 2x at this point, but just so you visually see it in the picture, x plus 1/2 of circumference is 2 pi r, or you would be saying that it's x plus 1/2 of pi d, if you like that option better. All right, so just separate all of these into shapes that we know, and then just very systematically decide if you're adding, like for the areas, if you're adding the perimeters, or if you are like taking two sorts of shapes, shape inside of a shape, and doing an area of the big minus an area of the small. Right? That's everything you need. Keep practicing.